Hello guys! In this video we are going to see some examples of implicit functions. You know that a function can be given in different forms and sometimes it's not easy to pass from one form to another. So let's put some examples. VIT. When I say VIT, I mean very important thing, okay? So in this case, the objectives are to understand the mathematical representation and properties of some algebraic functions, implicit functions, okay? And we are going to talk about circumference and cycles and ellipses, okay? And we will introduce the relation with these forms and shapes to the elliptical orbits or circular orbits, okay? Requirements: a little bit of algebra, a little bit of geometry, and some mathematical tools. Not so much, I hope. Okay, important equation, a very important equation, guys. It's going to appear many times, okay? In my subject, in many other subjects, in mathematics, in physics, in many places. Okay, so what is the general equation of a circumference of radius r and center at x0, y0? This is the formula. Okay, as you can see, the center is written here, then is x minus this center squared, y minus y0 squared equals the radius squared. Be careful with this example. With a normal or general equation of a circumference is x squared plus y squared equals 16. As you can see, there's nothing subtracting x, nothing subtracting y. What does this mean? That this circumference is centered at 0, 0, okay? And 16 is going to provide you the information of the radius. But be careful. It's a very common mistake to say, oh, the radius is 16. No, be careful. The value you see on this equation is the square of the radius. So when I see 16, the radius is 4, the square root of 16. Okay? Also, this equation provides you the equation, or the equation of the circumference in an implicit form. It's a function in an implicit form. You can solve for y or for x in this equation. If you solve for y, you will obtain what you see on the screen. X squared is moved to the other part, will be moved negative, that is the reason you see here minus x squared and minus x squared. Then you will have y squared equals something. In order to eliminate the square of the y, I need to take a square root. And when I do that, be careful because the solution is positive square root and negative square root. So I needed to split these two functions. So this equation provides you with two functions, not only one. The one function is y1, that I call y1 is the square root of 16 minus x squared. And the other function, y2, is negative square root of 16 minus x squared. You want to plot it in order to know what is the shape of these functions. Okay, you got it here. In blue, you have the positive square root, and in yellow, you have the negative square root. Okay, so you have the circumference in an implicit form, and then with the functions if you solve for y. Okay, so piece of cake. The idea is that when you need to remember that if you solve for y, what you are going to get is two functions. Remember that what you see on the plot cannot be only one function, because for each value of x, if it was one function, for each value of x you will have two different values for y. And this is something that cannot happen when we have functions, okay? For a function, for a value of x, you only need to have a value of y. Only one, not two, like in this case. Okay, so we are doing things right because here we have two functions. Positive square root in blue, negative square root in yellow. Okay? Another example. Very close to this circumference equation, we have the ellipse. The equation of an ellipse, the general equation of an ellipse centered at the point x0, y0, and with the major semi-axis A and semi-minor axis B is written like this. It's always equal to 1, don't change this number, and x minus x0 squared is divided by the major semi-axis, and y minus y0 squared is divided by the minor semi-axis or semi-minor axis. Okay? In this case, this is the shape of a general equation of an ellipse. An example, for example, let's see this example. I'm always centering things at 0, 0, so things are easier. As you can see, I just replace x0 by 0, y0 by 0, and the semi-major axis A is 5, so I just write 5 squared, be careful, and the semi-minor axis is 3, so I just replace B by 3. So this is the equation of an ellipse. Just by looking at this general equation, you need to A, recognize what it is, an ellipse. Second, recognize the values of the semi-major axis and the semi-minor axis that are 5 and 3, okay? If you want, this is an implicit function. If you want to solve for y in this case, you are going to obtain more or less the same. This expression will go to the other part, but negative. 3 squared will be moved to the other part, multiplying things, and then the y should be solved squaring both parts of the equality. So what I'm doing here is solving an equation, and as mentioned in every requirement, we need a little bit of algebra and calculus in order to do that. If you have any questions, please write me. My email is at the beginning, okay? But so we solve for y, and we have two functions, the positive and the negative. If we plot these two functions, we have the blue one, the one obtained with a positive sign, and the yellow one, the one below, obtained with a negative one. Okay, but this is the plot. Do I need all these things in order to plot these things? No. Please, take a look to the implicit function. I know it's an ellipse centered at 0. Okay, so I can just put 0, 0 in the middle. First things first. Then the major semi-axis has a length of 5, as you can see. 1, 2, 3, 4, 5. Okay, so I know this length. The semi-minor axis is 3. So as you can see here, this is 3. The length is 3. So knowing the semi-minor and semi-major axis, I can plot the ellipse. No problem with that. Okay, so as you can see, you don't need to solve for y and use software in order to plot these things. Just take care of what is each element in the formula, and you got it. Okay, so if the ellipse is an orbit, let's review some ideas of an orbit. This is the main body about which the satellite is orbiting around. This is another main body. There's nothing in there. I mean, there's the first focus and the other center of the ellipse. The word center is not well done. It's not well used. Center is here. Okay. This is the main body. This could be the Earth. Okay. The ellipse has two focuses. The major semi-axis is this length, as you know. Okay, and this is the semi-minor axis. So be careful, because I see many things in here. For example, if this is the Earth, this is the major semi-axis, I need this distance. I know to know what is this length, and I need to know what is this length. So let's put names to this. Oh, by the way, the ellipsis has something called the eccentricity that changes the shape of the ellipse. If this is the main focus of the ellipse and this is the secondary, so if we move them apart, the ellipse is like more flat. The closer we put the main focuses here, the primary and the secondary, as they get closer, the ellipse becomes a cycle. If we just don't divide the main focuses here, at the end we will have a circumference. Okay, so the idea is the farther they are the main focuses of the ellipse, the more flat it is. Okay, but this is hard to say because without any new definitions. The key point is the eccentricity of the ellipse. This is C, the length between the main focus of the ellipse, or the main body of the ellipse, till the center. This is called C. This is called A. So the quotient between C and A provides you with an idea how far is the main body from the center of the ellipse. The farther it is, the higher the value of the eccentricity it is. Okay, eccentricity will range in an ellipse from 0, if this is a cycle, to 1, never being 1. Okay, 1 is the maximum value, but it's never going to be reached in an ellipse. Okay, so eccentricity gives you an idea. If I give you an eccentricity of 0.01, that means this is not an ellipse. It's almost a cycle. If I give you an eccentricity of 0.3, oh, okay, wait a moment, this has the shape of an ellipse, it looks like an ellipse. If I give you an eccentricity of 0.7, oh, it's very, very eccentric orbit. It's very, very flat orbit, okay? So it's an idea of, it gives you an idea of the shape of an orbit, okay? So what is the radius of the apoapsis and periapsis? They are plotted in here. Let me show you. The radius of the perigee or the of the periapsis is this length. The closest point to Earth, this one. This is the radius of the perigee or the radius of the periapsis. And the radius of the apoapsis is this length. From the center of the Earth till the farthest point in this case. Easy relation between semi-axis and radius of the perigee and apogee. If you add the radius of the perigee with the radius of the apogee, what you have is double the semi-axis, the major semi-axis. Okay, that is a relation you need to remember, and it can be seen. A is that thing. Okay. 2 times A is the whole line from here to here. Okay, so 2 times A is the radius of the apogee, plus the radius of the perigee. Another formulas that are useful, for example, if you know the major semi-axis and the eccentricity of an orbit, you can know the radius of the apogee and the radius of the perigee just by using these formulas, piece of cake. This is the relation I was talking about. The radius of the perigee plus the radius of the apogee divided by 2 is exactly the semi-axis you can see in the plot. And the other relations are obtained just by using the formulas you have here. The ratio of apoapsis to periapsis is 1 plus the eccentricity divided by 1 minus the eccentricity. How is this formula obtained? Okay, just by replacing by these 2 expressions and simplifying A. And how do we obtain the eccentricity in terms of the radius of the apogee and the radius of the perigee? You can obtain the eccentricity using this formula. This formula is also obtained just by replacing these 2 formulas into this quotient, and it's very simple. Okay, so orbits. If the eccentricity of an orbit is between 0 and 1, we are talking about ellipses or circumference if the eccentricity is equal to 0. When the eccentricity equals 1, the ellipse is broken and becomes a parabolic orbit. Okay? We will deal with this A equal infinity or C equal infinity in these cases. But the key point is that if something is not orbiting the Earth, is going far away from the Earth, is not going to follow an elliptic orbit. It's going to follow a parabolic orbit. And also, if the eccentricity is even higher than 1, it's greater than 1, what the orbit is not anymore a parabolic orbit. It becomes a hyperbolic orbit, okay? This orbit will push, or if a satellite is following a parabolic orbit, it will leave the sphere of influence of the Earth, but it's not going very far away from that. And if it follows an hyperbolic orbit, then it can leave the solar system in this case. Okay, guys, what we have seen in this case is we just introduced the ideas of a circumference and an ellipse. We have seen what is the semi-major axis, semi-minor axis, and the relation with orbits. Okay, I hope you find this helpful, and thank you for your attention.